Hello, I think we're live. How's the quality, chat? Good afternoon, by the way, everyone. We'll be waiting about 5 minutes to start, so we'll just use this time, I guess, to make sure the quality and everything's alright. You can read everything on the screen. Fan sound. Is there like a noticeable fan sound? Is it that bad? I can't tell if it's using my headset mic or the laptop mic. As long as you can hear me okay, at this volume that I'm talking, it should be fine. Sorry. Turn up the mic, sure thing. Is this better? Extremely quiet. Protext. I'm not aware of that. I will go through a few options of how you can actually get LaTeX to work. Particularly Overleaf, I think, is the most convenient one. So at the start, we'll spend a bit of time like saying how that should work. I'm just gonna wait one more minute just for everyone to connect. All right, it's 4 o'clock. Let's get started. Good afternoon. everybody. Welcome to the MathSoc and CSESoc LaTeX workshop. My name's Nick. I'll be presenting this afternoon. So just a quick rundown of what we're going to do. So we've got 2 hours. We're going to spend 1 hour on the basics. So like how do you do math stuff, a little bit of how you like set up your document. And then hopefully, if there's time in the first hour, we'll do some things on like tables and images. There's no rush. There'll be a little bit of an introduction so you can set things up. So, and then in the second hour, we'll go through some more in-depth assignment stuff. So like how do you do some extra formatting? Hopefully a little bit of time on how you set up some graphs and some diagrams. So some of the more advanced stuff. And the slides do contain some extra material. So like how do you put source code in there or algorithms, or how do you do presentations? We probably won't have time in these 2 hours to go over that stuff. But there are notes about it in the slides, and the slides will be shared after the talk. Yeah, so the slides have like the most basic information. Most of what I'm going to be doing is here, I'll be going through some like live coding stuff. Yeah, so everything's going to be posted online afterwards, and ask questions anytime. We have people from MathSoc and CSESoc in the chat there to answer questions. So, all right, why are we deciding to run this workshop? This is sort of the problem I want to address, right? Every single course that uses LaTeX, the first time they say, oh, here's your assignment, we recommend you do it in LaTeX, they'll say, this is not a LaTeX course. They might give you like an example document or something, but they don't actually go into depth about how you should use it. You sort of have to figure that stuff out yourself. So we thought, we can do a workshop where we teach everybody a little bit about it and do some stuff interactively. Yeah, all right. So now a little bit of an introduction about LaTeX itself. So Donald Knuth was writing a bunch of books about programming, computer programming, and they just moved to like a new kind of typesetting in the industry. But he thought, this kind of typesetting is really bad. It doesn't look very nice. So as you do, he decided, I'll just invent my own typesetting language. And then that gave us Tech. And then LaTeX is kind of a set of tools built on top of LaTeX. Is the text in the presentation clear enough? Should I zoom in a little bit? Is that better? Can everyone see that all right? The source code isn't clear. I can zoom in on that too. Turn up the mic, sure thing. This document here. Yeah. Okay. Yeah, sorry about that. It's hard for me to see what's going on because I only get like a tiny version of the stream. Yes, so this is LaTeX code. We will, I'll explain what everything there means in a minute. All right, everything's clear now. Let's move on. So, why do we want to even learn LaTeX in the first place? So, it's become sort of an industry standard, mostly in maths and statistics, just because it's really, really easy to typeset things like equations and stuff. But also in anything else that uses a lot of maths, particularly in research, so like physics and computer science research. It makes it really easy to combine things like words and graphs and all the sorts of things that you would need in an academic document without really having to worry about the formatting. In terms of what you as a university student want to learn it, most courses involving some kind of maths assignment will ask you to use LaTeX. Well, as a preference. You don't have to, but particularly as you go along into later courses, they will prefer you to use it. Yeah, so this is a good meme that sort of explains why. I mean, with Word, it's convenient in that you get that sort of absolute control. You can move an image like a little bit to the left or a little bit to the right. But it's inconvenient, and that can sometimes cause a lot of inconsistencies, and the text just goes flying around the page. With LaTeX, you can get that kind of control, but generally speaking, it's designed for that to be out of your hands. You just put the text in the document and the equations, and it sorts everything else out for you. All right, so some environments. Just to start, this is Overleaf. This is what we recommend that you use, both for the workshop and for your assignments. So if you're a UNSW student, if you sign up to Overleaf with your UNSW email, you get free Overleaf Pro. And it hosts all your assignments on the cloud, so if there's any problems, it's backed up. And you can sort of like type the code here, so hide YouTube, and then you click recompile to see the effects. Everything's pretty instant. And you can add your own files into it here with this upload button. But for the presentation, I won't be using Overleaf. I'll be using my own local installation of LaTeX. But for you guys, you can just use Overleaf. Another note is this document here, without this section of text, is the sample that we'll be using for the first few parts of the workshop. So if you go onto the description, you should find a link to this sample code. You can just copy that and paste that into Overleaf, and then you can just type any of your equations into there. We want to start with just the math stuff, and then later I'll tell you or what is the use package stuff, or how do you set up the document a little bit more. But I will talk a little bit about the other options you have. So if you want to install it locally, you can use like TechLive or MikTeX. You can, and then there's Microsoft Word, right? If this is just one maths course and then you're finished with maths for the rest of your degree, I mean, that's probably fine. You still do get an equation editor, right? But I do encourage you to try LaTeX. How's chat? What about autocompile? Can't you just Control S? There might be some kind of autocompile option, but I'm not aware. I don't use Overleaf that often, actually. I usually use an installation on my local machine, but it can be quite a nightmare to make sure you've got all the packages if you do that sometimes, particularly because I'm on Linux. The document might be a bit unclear. I will zoom in when I am actually doing some more complicated examples, just so you can see what it looks like. For now, we're just sort of focusing on the slides. Yes, the slides will be uploaded, as well as like your recording and a bunch of templates that you're able to use for your assignments and your CV. I've got a CV template in there, or a resume template. So this is what the tech document looks like. You don't need to concern yourself too much with this sort of stuff. You just sort of put your code here. And so here we've got hello LaTeX. Now this is a command. So if you just type text, it just sort of appears as normal. But if you want to do something special, like put in a mathematical symbol in some occasions, or like include a picture or something like that, you have to use a command. And in this case, there is a command for the LaTeX logo. And so if I just compile that, we generate this PDF here that says hello LaTeX. All right, but this is basically something that you can do in Microsoft Word, right? So what about something more advanced? So this is what a formula will look like in LaTeX. I mostly just put this example here now so that you can see sort of the power of LaTeX. You don't need to worry about what all the symbols mean at the moment, but so if I put that in there, we have our sum of all the squares formula. So yeah, this is just to show like what the power of LaTeX is, right? We can easily create this really neat looking formula, whereas in Microsoft Word, you have to spend ages clicking around and making sure things are in the right place. So let's do a little bit more maths stuff. So there are two kinds of equations that you have in LaTeX. So the first one is an inline equation. So that's if, let's say, we want to describe this. So we say the sum of all squares, that is k squared, is as follows. So what we have here is an inline equation, which just means we want that sort of equation syntax, so we can do squares, we can do functions, all this stuff. But we want it to be with the rest of our text. You can use either a backslash and then the parentheses, or $2 signs for that. Generally speaking, I prefer the $2 signs because it's a lot more compact. And then you have block equations. So a block equation is something that sort of exists by itself. This is better if you have some really large thing like an integral or a sum or some really long derivation or some large fraction. It's nice to sort of break it away from the text, and then that'll be centered in the middle of the page, as you can see, and then get some space above and below it. And then you should use backslash and square brackets to enclose that, like I've done here. Technically, you can use $2 signs, but this is like old syntax, so it may cause some problems if you do that. So I prefer you just use this for block equations and then this for inline equations. Yeah, so most normal symbols are available just as is. So if you want to just type 3x plus 2 squared equals 0, you can just type that with this up arrow here, meaning like this is all to the power of 2. And then if you want Greek letters, it's just a backslash followed by the name. So let's say we wanted to change K to a different thing, so alpha. We can just do alpha, there we go. If you want an uppercase version, uppercase alpha just looks like an A. So how about lambda? Uppercase lambda, that should look like an upside down triangle, right? So that's a really good way to learn the names of those letters. You can just look up what they are if you want. And then fractions are variable using frac. So then frac pi 6 becomes pi over 6. So while it is possible to just do it like n over 6 like that, I mean, this works, but the problem is it's not, especially in this case, it's not clear whether this is n divided by 6 multiplied by these, or n divided by 6 multiplied by these. So in this case, you know, it'd be better to use frac, right? All right, how are we doing so far? How's the chat? Why do we need the backslash? Yeah, so the backslash is for any kind of command. So if it's anything that, like if I just left out the backslash here, for example, there's no way for LaTeX to determine, do you mean the Greek letter lambda, or do you mean just those letters? So the backslash there says, you know, this is a command. This is to be interpreted as like special text. You lost a game of League last night. Rip. I don't play League of Legends, so I can't relate. All right, moving on. So some more basic stuff. So sums are available using backslash sum. So for example, sum up in underscore k equals 1, 3 to the power of minus k becomes that. So this is actually a good example to work on. So let's change this sum. Let's look at a new sum. We change this back to k, and then so that's 3 minus k, and we'll just leave that computation. Right, so this is fine, but I want to make a distinction here. So when do we need these curly braces and when do we not? So let's see just what happens if we leave them out, right? Right, this isn't what we wanted at all. So what's happening here is that if you leave out the curly braces, LaTeX will say, oh, I'll grab the next thing that's after this. So in this case, it's up n, so that's like the limit of the sum, right? And that's what we want, right? We just want n on the top, so that's fine. The problem is we want k equals 1 to be on the bottom. I mean, even if I add a space here, it's not going to change anything. Because the problem is that LaTeX won't notice this space or anything. It'll just say, all right, so you mean k is on the bottom. And then equals is just part of whatever's inside the sum. So to get this treated as one whole thing, you have to put those curly braces around there. All right, so now we're getting there. But the problem is now this k is sort of below everything now, right? And it's the same for this up arrow here. This is probably one of the easiest ones to miss. I miss this one all the time because it's very easy for us to think of this minus sign as being like associated with this k. But LaTeX can't make that distinction. So you need these curly braces here as well. One thing you can do when you're setting out is just put curly braces in there by default, even if it's just around one thing. And that just sort of avoids that error. And then as you get better and then you get more observant, you can probably leave out those curly braces. All right, so what about integrals? Let's do this integral from the slides. So the integral of e to the power of minus x squared from negative infinity to infinity. So an integral is /int, and it's similar to the sum. So you use this up arrow to go the upper limit, and then you use the underscore to go for the lower limit. And infinity is \int ty. just to make it a little bit smaller than typing \infinity each time. So it should be -infinity, shouldn't it? And then, because LaTeX ignores spaces, you can add as much space as you want to make it more readable. So to the power of -x². I'm just going to put dx. I'll put a space in there, right? That should give us enough space. I mean, that looks pretty good. But the problem that I have with this is that there's not enough space between like the integrand here and the dx. The problem is because LaTeX ignores spaces, it doesn't use them for spacing things out. So in order to space something out in LaTeX, you can do \semicolon. There's actually a few you can use, but I find myself using \semicolon the most because it adds about the same as just pressing space normally. And so that gives us a little bit more breathing room. That's helpful if you have like something else on the end. You can really start to notice a difference. So if you have like fx on the end, and then you don't have that space, everything's sort of squashed together. Yeah, and we can have some special mathematical symbols here. So as long as you're using the sample document, you should be able to do things like x \in gives you like that in a set symbol, and then mathbb for math blackboard r. So that'll say for all x in the real numbers. As long as you have this sample document, particularly as long as you have these two packages here, you should be able to do that. All right, how's chat doing? Any questions so far? No? All right. If you have questions, yeah, just leave them in the chat. And someone from CSESoc or MathSoc might answer them. Or if they're a really good question that I think I should speak about, then I will bring it up. All right, now this is the important section. If there's one thing that I want you to take away from this talk, which packages? So it's these two packages here will give you the real numbers and all these other useful mathematical symbols and commands. So I'll talk about that a bit later, but generally speaking, whenever I'm working with LaTeX, I import actually these 4 packages just sort of on reflex. All right, so yeah, if there's one thing that I want you to take away from this talk, it will be this. So this is a very common sort of beginner mistake. We want to do like sine x plus pi over 2 to the power of n. Let's do that. So it's going to be frac pi 2, that's to the power of n. Now, I mean, this, it works, right? We've got our point across, you know, we can read it. The problem is 2 things here. So sine is all in italics, and that's because LaTeX is looking at this and thinking, oh, well, that's actually 3 variables, s, I, and n. And here, these brackets don't match the size of the fraction which contains them. So there are 2 solutions to this. The first one is LaTeX includes a bunch of commands for the common functions. So things like sine and log and exponential as like writing exp and then brackets. Things like that. You can just do \sine. So that puts it in like, you know, upright text, and it adds a little bit more space between this bracket and the n. And then for the brackets, it's possible to manually adjust the size of the brackets. But I don't recommend that you do that. What I recommend is you just do /left anytime you do a left bracket. and then /right anytime you do a right bracket. You don't need to do that every time. So it only really matters if you have something like this, where you have a fraction or some really large sum or power, where it starts to grow higher than the brackets support. In that case, if you put left and you put right, it will automatically resize the brackets. These two mistakes are really, really common. You even sometimes see them in like the lecture notes for a course or the course notes or something like that. Particularly the bracket auto sizing thing. People really often forget to auto size their brackets. It's not, the end of the world if you forget, but it's useful to know how you can deal with that. It just makes things look a little bit neater. Any questions so far? What app am I using? So the PDF of the LaTeX thingamabob updates instantly. This is just the default document viewer built into Ubuntu. So whenever I recompile it here, it will update on my PDF viewer. I just recommend that you use Overleaf, and then every time you recompile an Overleaf, it will just show up. So this is essentially functionally the same as using Overleaf. Will I also be talking about citing references in the docs? So there are bits in the slides that mention how you cite references like in a full format. I'll quickly go over the easiest way to cite a reference. Let's say that you have like one reference. You can do \footnote. Let's say Euler. Let's say that Euler is still alive. Euler 2020. And then that puts like a little footnote there. And if you go all the way to the bottom of the document, you have this reference here. And you can put whatever you want in there, like a URL or something like that. That's useful if you just have like one reference that you want to put in. If you have multiple references, you need to use like a proper bibliography environment. But there is a way of doing that. Yeah, so this is the solution. Just a note. So if your function doesn't have a command for whatever reason, you can add your own using like /operator name or like /declare math operator, but you shouldn't usually need to do that. Particularly in first year maths, you should normally just be using functions that exist in LaTeX anyway. Is there a recommended formatting style for assignments? What I will do is after the talk, I have like a template that you can use for your assignments, and also this template that I'm using here for this basic document, and also a CV and a resume template, and then I'll upload them with the slides and everything else. All right, now let's take a look at some more advanced stuff. Just zoom a bit. So, there are two other environments that are useful to look at. So when I say environment, what I mean is, so here we have a /begin and a /end. This is like the main environment that everything's contained in. But you can also have smaller environments. So one example might be, let's say that I want to center this piece of text here. I can do, where's that? Okay. Begin, center, and end, center. And then that moves that to the middle. So this is the center environment, and it means everything between these is going to be centered into the middle of the page. But there are also environments that can help us with maths. So the first one is, let's say that I have some sort of complex derivation. So let's say, all right, fx plus gx equals 1 plus 1. And then because this working out is like so complex, I can't possibly fit it into one line. I have to add a new line that's like, and then all of this obviously equals 2. Alright, so this is fine. But the problem is this equal sign here isn't aligned with this equal sign here. So how do we do that? How do we get all our working out to sort of line up properly? So the way that we can do that is using the align environment or the align star environment. I usually prefer align star. So what you can do is begin align star and end align star. And then we just take our equation here. You don't need the square brackets anymore because those are sort of added on by the align environment. And then it's used, you don't actually have to align them up inside the document, like inside the text here, but I find it's useful too. And then you add an and symbol wherever you want it to line up. So in this case, we want it to line up just before that equal sign so that all the equal signs are lined up on the page. So we put an and just before the equal sign. And this won't actually show up in the document. And then we put 2 backslashes at the end of one row. So if I leave these out, it will assume that this is all one row. And so we get the equals 2 way off to the side. But if I put those in, now everything's lined up. So that's really useful when you show like a lot of working out. And one example, this is just one example with the equal sign, but if I wanted to do like, let's say I wanted to use those implication arrows, right? I can do backslash right arrow with a capital R. This like implies. So I could do something like that. That's more useful if you're making some kind of like argument rather than showing some derivation. Hide the sidebar for PDF documents. Yes, I can do that. Thank you. Go back one slide for the top right slide and make it clearer. I can make this a bit clearer. Yeah, so that the slides will be available after, but I do want to make sure that everyone can read it and sort of follow along. Doesn't AMS Math have an implies command? I'm not aware actually. I've always been using right arrow. Let's try that. Implies. Huh, yeah it does. That's a little bit longer than the right arrow. Interesting. Yeah. There's always too much of LaTeX to know everything, so it's always nice to see something new. Alright, so this might be something that's a little bit more useful for your assignments. So things like P matrix and B matrix. I don't think you've gone through matrices yet, but a matrix is the same kind of thing as a vector. It's just sort of like a bunch of vectors organized in a row. So how do you have one left aligned line in between 2 center aligned lines? So I guess what you're talking about is if I wanted to do some kind of argument between these, how would you do that? I'm actually not sure. Usually when I need to add some kind of explanation, I just add an explanation and then just restart the derivation from where I left off. Maybe someone else from MathSoc and CSESoc can comment in the chat if they know, but unfortunately I don't know. Why do I add the 2 backslashes? Yeah, so if I don't add them, then LaTeX can't tell the difference between this and this because it sort of ignores the white space. So then if I compile that, it just assumes they're both on the same line. So if I add those backslashes, then it sort of puts them on different lines. When you put the and character in the second line, it doesn't shift. Yeah, make sure that you remember this, these two backslashes, and you remember the and symbol in the first line as well. So if you leave that out, it might not be aligned properly. How do you do an if arrow? How I do it is left-right arrow. Like that. Is it possible to have two separately aligned bits of text in the same line without using hfill? The only way that I know of to do that would be to use a table and then have two columns, one left aligned, one right aligned, and then, yeah, that's, unfortunately, I can only think of a table for doing that. Usually I do just use hfill, though. Yeah, right, so matrices. Let's use this align environment. So let's say that I want to, well, we'll start with just a vector, right? So mathbf will give us a bold letter X, and then so P matrix. So a matrix environment is something where things are sort of aligned in some kind of grid, and then P matrix means a matrix surrounded by parentheses. So let's say that the vector is going to be 1, 2, 3. I'll get rid of those extra new lines there. There we go. So that's how a vector looks. And you can have any sort of maths in here. So let's say you want to do like x1, x2, and x3. And that would look like that. And you can also do, so let's say that we wanted to add two vectors. Right? You can have a plus sign, and then you just copy and paste this P matrix environment here. So let's say this is like y1, y2, y3. Right, and that's a really neat way to type out your vectors in the tech. So we mentioned before, a matrix is kind of like vectors written side by side. So if you've finished 1A already, then, or you went to high school outside of New South Wales, you might know what a matrix is already. But to get a matrix, you would do like this. So you put an and symbol in again, where you want to align things. That's sort of like a common theme in LaTeX. So if you have some sort of environment where everything's lined up with each other, you use and symbols to align things, and then two backslashes to signify a new line. So in that case, we get the x's there and then the z's there, and it's sort of in one thing. And that's a matrix. And what about piecewise functions? That's another good thing to look over just quickly. So let's say that I wanted a function which is 0 for negative numbers and 1 for positive numbers. Then I can use cases. So begin cases and end cases. And this uses that aligning type thing as well. So we give case 1, which might be 0. And then I can say that's when x is less than 0. And then 1 when x is GEQ is greater than or equal to 0. Yeah, and so these and symbols again will line up. Will line up the 0 and the 1, and then we need these two backslashes to say that this is like a separate case. And then if you want, you can also do like you can do like /text to add text. So you can do like the otherwise case there as well. Can we do one-liner vectors? Yes, you can. Probably the best way to do a one-liner vector is you do an inline thing, and then you do so we use p matrix here, and then we'll do like x1 x2 x3. And so that's kind of like a one-liner vector. I prefer, if I'm doing a one-line vector, to just use normal brackets and then commas instead. So x1, x2, x3. Oh, and of course, because you got to have the vector in the right direction, right? You got to transpose it. So and t. A good thing to note, if you want, is let's say that you want to add some dots, right? A nice way to do that is, I mean, you can just add like dot 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 and then xn. So that's one way. You can also do so dots C will add some dots for you. You can do dots B, and then the dots are sort of like raised up. That's useful if you're doing dots in some kind of like long sum, rather than dots in something that's separated by commas. That's something that's sort of up to you, but I think it's nice to show. V matrix is used for determinants as well. Yeah, that's a good point. So if you're doing determinants of a matrix or something, you could use V matrix. So there's V matrix, which will put those vertical bars. There's B matrix is what I used here. That puts like square brackets around the matrix. All right. That's all at the moment for the maths stuff. If there's anybody who's going to leave after the math stuff, there's a few things that I want to show you just quickly at the end. So the first one is just a bunch of useful links. So at the end, we'll put all the slides and all these resources up on the website. But there's also a bunch of other useful links here for if you need some extra resources. So like, where do I find a particular package that does this thing that I want? Or where do I find this symbol for this one particular thing? Or there's also a Stack Exchange where you can ask questions or view questions that have already been asked. And also, if you want to leave after all the math stuff, we do ask that you fill in this feedback form for us, just so we know what went well, what did we do wrong, and so on. Where will the slides be uploaded after we finish? It should be uploaded to the MathSoc website. We will put a link in the event page. All right, let's keep going. So a little bit about how do you set up a document now. So we've been doing all of this in a document that I've sort of set up for you for the sake of convenience. But I mean, if we zoom out to like fit the width of the page here, there's not much going on this page, right? It's just our maths. So how do I present this in a way that looks like a proper assignment? So a little bit about the structure here. Everything that is above the document is called the preamble. And so this contains this line here, so document class. This is like, what kind of document is it? Are we writing an article? Or are we writing a book or a presentation or something like that? Most of the time, you'll just be writing an article. Article just sort of provides everything that you need. And then you have use package. So this lets you import some useful packages. I always import these four. We will go over some other packages that you can use, particularly some really powerful packages for including like images and graphs and so on. The one that I haven't mentioned so far, I'll just delete that now because we're going to replace it. The one that I haven't mentioned so far that is really useful is the geometry package. So yes, so these are essentially the same as libraries. They just add a few extra commands to LaTeX and stuff. Yeah. So the geometry package here allows us to change the sizes of the paper and stuff. So LaTeX is an American thing, and so the default paper size is US letter, which is very slightly different to A4. It's unlikely that you'll notice much of a difference, but if you want, you can specifically say use A4 paper. And the margins, by default, are set to be ridiculously large. There is a good reason for that. Well, two good reasons, actually. The first reason is they did a study that said lines have to be this many words long for people to have the best attention span if they're reading it. So they calculate what the optimal line size should be for your text size and your page size, and then calculate what margins should give that line size. But those are likely to be bigger than you would need, and you're probably not going to be writing a lot of text in a maths assignment. It's mostly just going to be equations. So if you want to just reduce how many pages you have, you can reduce the margin size to about 3 centimeters, or maybe 2 centimeters if you're really strapped for space. The other reason why they like to set large margins is because if you're writing a mathematical paper, as an academic, it's useful for other people to be able to print off the paper and then make notes in the margins. So Fermat, the reason why he couldn't come out with that proof for his last theorem was just because somebody had imported the geometry package and set the margins to be way too small. Yeah. This is another good thing to note as well. So let's say that you want 2 columns. You can also do 2 columns here. So if I add a bunch of text, let's say blah, 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 over and over again. So if I had a whole bunch of text here and I have this 2 column, it will adjust it to be in 2 columns. You wouldn't normally do that for your homework. Normally you just have it on 1 page, but if you're doing some kind of article, usually it's in 2 columns. That's just a side note. Metadata. So this is where things start to get useful. So virtually all assignments will want you to have some kind of title and then some mention of your name and your ZID and so on. So the way that we do that in LaTeX is really simple. So let's say my homework. Nick. The date, we'll make a few days in the past so that we can trick the lecturer into thinking we're good with our time management. So March 17th, 2020. Right. So on the surface, this hasn't changed anything. Now it will actually change some details of the document. So now the author is going to be listed in the document's like underlying properties, but it's not appearing visually. So the problem is all we're doing now is setting up some properties for the document. We're not actually rendering anything. So what we need for that is make title. And then that adds a nicely formatted title to the start of the document. One thing that you might find useful is if you don't want to enter the date all the time and you do /today, that replaces the date with the day that you rendered the document. So that can be useful. It's sort of up to you. Another thing is, normally if you're doing a report for maths or something, you want to put your ZID as well as your name. So for that, you can do 2 backslashes to like force there to be a new line, and then you do your ZID. Yeah, and you can add as many people as you want into the author field. So let's say that I want to add my identical clone. And this is good for group assignments. So there are a few group assignments. Math 2901 has one, for example. Yeah, and these are the other essential packages that I've already put in your samples for you. So the first one are AMS Math and AMS Sim. You basically can't get away with typing out maths without these packages because they provide you with things like the real number symbol and the align environment and all these other comforts. Microtype, I've never actually noticed what this does, but it makes really slight changes to the way that the letters are drawn onto the page to make it more readable. So I just generally include that anyway. And parskip, so let's say I'll comment this out. I'll comments in LaTeX, by the way, are a percent sign at the start of a line. So I want to comment out parskip. Then you'll see that all of my text is sort of shifted. And that's because if I just add some text here, by default, LaTeX will indent the start of a paragraph. Now, this is sort of a matter of personal preference. Some people are okay with this. I don't like it. So I import the parskip package to turn that off. Sections and subsections. So this is useful for your maths assignments because you often have a bunch of different questions. So let's say this is going to be question 1. I can do section, question 1. And let's say that I want to have question 2. Alright, so now I've sectioned it off. It's taken care of all the formatting for us. It's even numbered them. But the problem is, it's redundant to have it be like 1, question 1, and then 2, question 2. So how do we get rid of the first number? It's sort of built into the section. So in this case, we use an asterisk. It's the same with align star. So actually, if I take away the star in align star, whoops, I just hid everything on my desktop. If I take away the star and align star, then it numbers it with this 1 here. And that's useful for, like, if I want to say, according to equation 1, right? It's useful if you want to reference that. Generally speaking, though, I don't put those kinds of things in. So I prefer to just turn off all the numbering. Yeah, and so it's the same with the section. You can do like section star. All right, and you have different levels. So let's say that you have some sort of subpart here. So there you can do subsection, part B. Part B was really hard. Part B is really hard. I didn't solve it in time. And then this is going to be a little bit smaller. And you could do like subsections and so on. And the sections that you get depend on your document class. So like if you were writing a book, you can also get things like chapter and so on. But you're not likely to run into that doing your maths homework assignments unless UNSW suddenly gets like a lot harder and you have to start writing maths books for your assignments. The other thing is you can use the hyperref package to add links in a PDF viewer. So to do that, you do hyperref. This is just a package which provides a bunch of like general tools for writing into PDF documents, because PDF documents can have links and stuff in them. And then you can do hyper setup true. The problem with this is that in order to get it to put the links in, you have to have numbered sections. So if I recompile that now, and then I reopen the sidebar, I might have to recompile it twice. Yeah. So now, I don't know if you can see that too well, but will the video be available after the stream? Yes, it will. It should be recorded. If it's not, you'll still have all the slides and all the examples. The examples will be slightly different, but they will cover roughly the same material that the examples I'm doing here are. So yeah, everything should be available afterwards if I'm going too fast, but I will slow down a little bit. We're doing quite well for time, so yeah, if I am going too fast, yeah, please let me know. I can slow down a fair bit. So yeah, if I take out those stars, then I get these references here. If I click on them, it'll take me through the document. And then also adds these things, so like here, will take me straight to the footnote. So that's something that's very useful. Yeah. Since it's 5, I'll take a little break for questions. How are we all finding the stream so far? Is it bad to use therefore? I mean, in the sense of LaTeX, no, it's not. But in a mathematical sense, I think they try to discourage it and would prefer that you use implies, unless you're doing logical reasoning type stuff for discrete maths. It is unlisted, but we will post the link on the event page in case anybody loses the link for whatever reason. Let's keep going then. If you have questions, I mean, you can ask them anytime. I just thought I'd spend a few minutes dedicated to just checking the chat. All right, now let's move on to some more report type stuff. So how do we do tables and how do we do images? So the reason why, I mean, tables are useful for reports, just generally speaking, but the reason why I want to go over images is because there are some things like graphs and diagrams and stuff which is possible to do in LaTeX, but it can be very hard. So it's sometimes easier to just do it in some other program like Excel or PowerPoint for a document, for a diagram, something like that, and then just screenshot it and include it as an image. And also sometimes you want to put an actual image in your reports. So let's put this in part B. So the motto of tables in LaTeX is to just use book tabs. So by default, a table in LaTeX looks kind of bare bones. I mean, it works, but it doesn't work well. So I'm just going to copy over an example that I have prepared earlier in the interest of time. So here we've got a table. I guess it's hard to start with to see what everything is doing here. So let's go from the top. So this is a table environment, and that encompasses the table and also everything that's used to describe it. So here we also say, our table should be centered on the page. And then here we give a caption, so what's in the table. And then here we have the actual table itself, which is misleadingly called tabular. So I'll just comment these out because they won't appear just yet. So it's the same as with a matrix or with any kind of align environment or whatever. So you have these and symbols to align everything, and then you have the 2 backslashes to put things on new lines. So we'll go ahead and compile that. Right, so now we have this table, right? But there's no lines. So to add vertical lines, you could put vertical bars there. Now we have some vertical lines between the columns, but there's no horizontal lines. So for that you can use hrule. And then if we have hrules, you should also have, well, if I leave that out, wait, is it hrule? I'm so used to using book tabs that I forgot what the actual command is. All right, let's just go with book tabs. So book tabs provides a whole bunch of features that makes typing out a table more easy. So we're going to go with that. So with book tabs, there's no need to include these vertical bars. And you just do a top rule for the top of the table, a bottom rule for the bottom of the table, and anytime you want some kind of divider, you have a mid rule. And that's a much better looking table. Now, it's possible to also include the vertical bars like that. The spacing will be a little bit off because of book tabs, but generally speaking, I recommend that you actually don't put in the vertical bars. The spacing and the alignment is usually enough to see where that where the columns start and finish. So the recommendation is that you use book tabs. You don't use any vertical bars or any vertical rules. You just use like the horizontal rules, and you use alignment to separate everything. So you also have a bunch of different column types at your disposal. So the first one is L, so left align a column. The other one we're using here is R, so right align a column. You can also center. So that will center align things in the column. I wonder if, can the mods actually ban him? I don't know how to do that. I just ignore it. The other thing which can be useful is the P. So P means paragraph. But what that means specifically is, let's say that I want to have like a whole bunch of text here. So again, we'll have like blah, 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 blah. All right, that overflows beyond the edge of the page. And the problem is there's not going to be any kind of text wrapping inside a table cell in LaTeX. It's just going to expand to fill whatever's in there. So if you want to have a lot of text, you should actually use the P alignment, and then you specify a width. So let's say 4 centimeters. And then that causes it to be left aligned, but it will add new lines as you need them. That's very good if you're doing a report and you want to have some kind of like comment in your table or something descriptive. I'll change that back to left align. And this is also something nice to mention. I won't demonstrate how this works, but what's the difference between top rule, mid rule, and bottom rule? So it's mostly in the, yes, they do basically do the same thing. It's mostly in the thickness. So if you zoom in here, you'll notice that the top rule and the bottom rule are a little bit more thick than the mid rule. I guess you could use the top rule for both, but I just like to use top rule and bottom rule at the top and the bottom. I guess it's just more descriptive. If I use overleaf, is it automatically compiled? I think there's a way to turn that on, but if it's not turned on, you can just click the recompile button whenever you change something. Yeah, something else to mention is there is a package called PDF Elscape, and if you look up the documentation for that package, I won't go into it here, but you can essentially make one page of your document be landscape. That's really useful for if you have a really, really long table and it doesn't fit in one vertical page. I think the only instance that I've used that is in the Comp 2521 sorting lab, where they have you write all these things in one big table. It was just easier to put that table in landscape so that I could have enough space to put the descriptions of what's going on in there. Right, and images can be inserted using the GraphicX package. So what we need to do first is include that package. So use package GraphicX. And then I'll just get some pictures. So get a picture of a parrot and a bee. And then let's add them here. So to add a graphic to a document, you do include graphics. And then you just put the name. So on Overleaf, if you want to include the graphics, you have to upload them first to Overleaf. So there should be a button on the sidebar where you have your tech file and so on. There should be a button that says upload. If you click that, you'll be able to select an image to upload. So one problem is, by default, include graphics will just put the image in the document, and it won't make any attempt to like scale it to a reasonable size. And usually, images are much bigger on the page than they should be. So the way to combat that is to do something like width equals 5 centimeters. And then that keeps the aspect ratio, but it keeps the image down to a reasonable size. Is there anything on images as well? Okay, figures. Yeah. So with a figure, that's kind of like this table environment, but for an image. So it's the similar sort of figure H. Oh, by the way, I will go over what this H means in a minute. Figure. Centering. D. And now it looks sort of like how a table looks. So we've centered it, we've got a nice label that we can refer to. Yeah, everything's looking good. And let's say that I want to add a picture in. This is going to be the parrot. Right. So this is the one problem with figures in LaTeX, is that it can be hard to position them. So we've got one at the bottom of the page here, and then another one is like on its own page. So this here allows us to change the positioning of things. So H means put it literally here on the page. T means fix it to the top of the page. So if I recompile that, suddenly the B is at the top of its page. But it's not at the top of the page that it was on, which is interesting. If I do B, it fixes it to the bottom of the page. So now it's sort of where it was before, but it is below the footnote. And then P, I'll just show you what that means. If I put both of them as P, that ends up putting them both on a separate page, which is just for all of the figures. So if I also make this table P, then that table gets put on this page as well. The problem with these positioning things is that it's kind of just a suggestion to LaTeX. It doesn't have to listen to you. It'll just put them wherever it thinks it's appropriate. Even if you do H, it doesn't always put the figure like literally there if it thinks there's going to be some sort of weird spacing problem. What I recommend you do is you use H, and then if you do have these positioning problems, just make all of your figures P and then have a separate page just for your figures. And then in your text you can say like see next page for figures. All right. Before we move on to the graphs and the diagrams section, are there any questions? Good question. Should we insert multiple dates within each page and section to keep track of when we edit our documents? I don't think that's possible to do. It's like if you want to keep track of when you're editing a certain section, you can add, so you can add comments wherever you want in the document. So let's say I wanted to add a comment here. Nick is cool. And then that won't get rendered. And you can use that to kind of keep track of what you're doing if you like. I think Overleaf also keeps track of the history of your document for you if you have the Pro account. The date that appears here is more of like a aesthetic thing to show when the assignment is done, or when the page was rendered, so to speak. All right, let's get on to some fun stuff. So graphs and diagrams. So it's possible to do your graphs in something else, like maybe, Desmos, GeoGebra, GNU plot, for example. But with LaTeX, you can really do some really powerful graphs. So, here's one here, right? It's even a 3D graph, which we've managed to do with just some LaTeX commands. And this is native to LaTeX as well. This is like part of the document. I won't go over the 3D graphs in the examples that we do in the stream, but the presentation's source code will also be available. So this presentation that I'm also, like the slides and everything, was also done in LaTeX. So this graph is actually like included in the source code of the presentation. So if you like, you can go and check that out. But we will do a little bit of 2D graphing. So LaTeX is really good for paragraphs and equations and all that sort of stuff and layout. The problem is it wasn't really designed with graphing in mind. So the way that you do graphing in LaTeX is you have this separate library called PGF plots. And that defines its entire own language, essentially, for plotting graphs. So let's take a look at how that works. Let's add a little graph. So first we're going to do a scatter plot. We'll do the scatter plot just here under question 2. So we'll get rid of all our pictures and tables. So first off, we need to actually include these PGF plots. So up here, we'll do use package PGF plots, and then this is to tell PGF plots what version of the language it should be using. You can copy that like PGF plot set compat equals 1.16 without really thinking about it too much. I mean, that's what I do. But if you're curious, that's just to tell it like which version of the language to use. So then if we want to add our graph, we do begin, takes picture, and end takes picture. So PGF sits on top of this thing called TIX, which is like a different language again for drawing diagrams and so on. So that's what we're going to do for the diagram section as well. And then we want to do begin axis and end axis. And this is what tells TIX and then PGF plots that we're actually drawing a graph. We're not drawing a diagram. Is that going to work? Yeah. So now we have this sort of blank graph, nothing on it. First off, we'll get some data. So in this data file, we have 3 columns. So the first one is like a number. All right, so I should explain, this data file describes how long it takes a particular algorithm to run. So this is like the number of elements in the input. This is the amount of time it takes Nick's algorithm to run, and this is the amount of time it takes other algorithms to run. And so as we go up, as you can see 2,000 elements, my algorithm's like really fast compared to other algorithms. So we start by using /addPlot. And so this adds like one line or one set of data to this blank plot that we have. So let's start with graphing my algorithm. So let's just say add plot data.txt, so pull the data from this file. And then will that be enough by itself? Wait, oops. Right, so by itself, it doesn't know how to interpret this file. We need to give it a little bit more information. So to start off with, we put 2 brackets here. So this pair of square brackets tells it how to draw the graph. So let's say we want it to be red. And then we say it's a table, which makes it like a scatter plot. And then we say the x column should be this num, so the number of inputs. And then y equals nic. So those were the fields at the top of the file. All right, now we have a graph. Problem is, this is a connect the dots scatter plot, which my science teacher always told me never connect the dots in a scatter plot. So how do we make it just the dots? So to do that, you do only marks. These properties here, so like color, red, only marks, they are like somewhat descriptive, but they can also be hard to remember. Right, so now we just have these dots. And then what if we want the other column? We can basically just copy this and then say, so the other column name was other, so y is other. And now we have this other pair of dots, but we can't distinguish them. So we should also change the color as well. Blue. There we go. Anyway, I wasn't looking at the chat for a while, so let's look at the questions. Should we insert, is this programming language called Tech? So there's, Tech is like the core system. You don't usually use Tech. And then, ticks. So you're asking about like ticks, yeah. So ticks sits on top of the Tech, which sits on top of Tech. Ticks is it's only different in the sense that it has a different set of commands, and then usually what you're typing looks quite a lot different to regular LaTeX, but it uses the same kind of syntax. So backslash for commands, square brackets for optional properties for some command, curly brackets for the argument of a command. It does get quite a little bit more different when you go into diagrams. The one thing I should mention is this. I really should put this slide a little bit further towards the front. So, as it stands now, it's kind of like, yeah, you're showing me all this, but how would I know what command to type to get this particular thing? The easiest way really is just to Google it. And after enough Googling, you'll sort of memorize what should be what. And then you might be thinking, doesn't this take a long time? It'll take me a long time to learn this stuff. Yeah, so I kind of recommend that as you start, you just use something like Excel to plot your graphs, or GeoGebra or something like that. And then as you get better with LaTeX, you might think, oh, well, maybe I'll try using PGF plots in this assignment or something like that. I just think it's something nice to show you, to sort of demonstrate the power of LaTeX and what these libraries can do. Like, some of these libraries are very, very large and capable of quite a lot. And it also does look very nice. So, all right, going back to our example here, we can also make this a figure. So if we do begin figure and end figure. And then we can do like a caption. Experimental data. And then here, do slash centering. And so that's the same. Oh, we also need to say H to say like put the figure in this position. Yeah, so that's kind of like, you know, if we had an image, we can also do that for graphs as well. But let's say that we're not dealing with, yeah, so let's say that we're not dealing with experimental data, we're dealing with a function. We want to plot some kind of function. So let's have that. Let's have in part, I'll get rid of the maths here as well. Let's say in question 1, we're doing like some theoretical analysis of this algorithm, which involves some mathematical functions. We'll just take this graph and copy it for the time being. But we want to get rid of our plots because we're going to change the way that it's plotted. And then here we're going to say theoretical analysis. So how you plot a function in PGF is actually quite a bit simpler than plotting experimental data. You can just do add plot and then your function. So let's do square root x divided by 2. And then, actually I think that should be enough. Adjust that out. No, right, we're getting an error. By the way, errors in LaTeX can be very, very difficult to understand. So if you see an error, your best bet is to just copy the relevant part. So here paragraph ended before, and then maybe like part of the command. And then, so you copy that, you paste it into Google. And more often than not, you should actually see some kind of Stack Exchange answer or something that can help you out. In this case, we get all this information, but I believe really it's because we're missing a semicolon on the end of this add plot. You don't normally need semicolons in LaTeX, but in TIX or in PGF, you do. Right, so now we've got this plotting of this function here, square root x. And you can see it has that characteristic square root graph shape. The problem is we don't have any control of we don't have any control over like the limits or how it looks or anything like that, but we can add that. So one thing we might do is set the domain. So from 0 to 2000, and then samples. So how it actually does it is it just takes samples of the function and then puts lines between them. So if you want to get something looking reasonably smooth, you could do, let's say 100 samples. And then we're going to make it red. Yeah, that's looking a bit better. And you can see it's automatically changed the size of the axes as well. So what if I want to change the axes and how they look? So it's a box at the moment. That looks a little bit weird. You don't normally see that when you plot a mathematical function, right? So that's actually up here, you put some square brackets. And then you can say axis lines left. And then that changes it to the axis lines that we used to. Right, now we're getting somewhere. Let's add the other plot. So other algorithms, their complexity, we'll put them in blue as usual, is x divided by 100 times square root of x squared. There we go. And actually that matches up quite well. What if I wanted to change? What if we did sine? Would that be noticeable? Yes, it would. Yeah, so you can sort of add whatever you want there. You can do sine, you could do logs. I'm not sure what exactly the limits of what you can do are, but most mathematical functions you can plot with PGF plots. It can be very useful. So there are two other things that I want to address before we move on, which is labeling. So this graph, I mean, I tell you it's the theoretical analysis, but we don't know what the x-axis is, and we don't know what the y-axis is, and we don't know what's blue and what's red. So to start with, we can label the x and the y-axis. So x label, that's going to be input size, and the y label can be instructions. So how many processor instructions does each algorithm take? There we go. So those are quite nice looking labels. And we can add the units there. Well, there are no units in this case. Let's say instructions, we want to put MIPS. Yeah. That's sort of up to you. And you can put mathematical stuff in here. So let's say the y label here is going to be like big O. And then with the $sign to say that it's like maths. And you can do that as well. So you can have like, f of x as the y label, for example. And the other thing is a legend. So here we have use add legend entry to add the legend entry. So under here, we do add legend entry. And then what that says is it says whatever plot was before this command, you give it this name in the legend. And then the second one, other algorithms. There we go. And it's generated that legend for us. All right, that was quite a lot. So let's get the chat again. Any questions so far about graphs? Alright. Yeah. It's hard to give like a general overview of graphs. I've tried to cover sort of the most basic stuff so that you can go ahead and plot some functions in your assignments, for example, and then maybe add some sort of so you can also add maths here, for example. That's really useful if you want to just plot some function. So here I might say that's O square root n, for example. So this is sort of, I think, enough to go ahead and do your assignments. But in terms of like a general overview of how you would graph things in LaTeX, I think that's not something that we really have the time for. It's better to just Google the things that you want to learn. And if you don't have enough time, just use something like Excel or whatever. All right, what about some diagrams? So we'll get rid of these plots for the time being. If you're worried about copying all that down, there are very similar things in the examples, so don't worry. So here we have this diagram here. So this is all done using ticks. I don't know the actual solution to that. I just used it as a way of saying you can draw these like really complex shapes if you want. So it's a similar story as with PGF plots. LaTeX isn't really set up for drawing diagrams. You have to have this sort of separate language called TIX, which does everything you want. And as before, there is a lot of things to learn with TIX. It's better to just Google what you need, and if it takes too long, you draw it in some other software package or just on a piece of paper, and then take a picture maybe, and then use include graphics to put it in your documents. And there's I've got a few notes here about how you can draw stuff. So what we're going to be drawing is a little physics type system. So we're going to be using the same sort of figure here. So what's the caption? Experiment. This is a physics experiment. And then we use that same TIX picture environment. Oh, and also with TIX, you don't need this use package PGF plots. You need instead use package TIX. So let's start with just a circle. So here we say, all right, we want to use draw to draw outlines and fill draw to draw filled shapes. So let's start with draw at position 0, 0, a circle. Now when I say position 0, 0, those positions are relative. I'll show you what I mean by that in a second. Right, so we don't see anything at the moment. What if I said radius is 1 centimeter? Now we get a circle. So these square brackets let you put in the options for what you're going to draw. So in this case, we want a 1 centimeter radius circle, a position 0, 0. But you can see it's been put in the middle. Now let's say that I want one that's 3 centimeters to the right. Then it's just going to move it 3 centimeters to the right, but it's still going to recenter the diagram. So all of these coordinates are sort of relative, and you can also go negative. So maybe one is going to be minus 3 centimeters, so 3 centimeters to the left. That looks like that. And this can be very helpful for drawing complex diagrams. And you can also add some properties here. So you might say, want it to be blue. And now we've got a blue circle. And then you can also do fill draw and then say fill it in as blue. There we go, a blue circle. And then we can also add some lines. So how you do a line is you do /draw. Then you put in the point that you want the line to start at, so 1, 0. And then 2 dashes to say the line goes from one place to another, and then -1, -2. And then we have a line coming off this circle. This is actually enough to draw quite a lot of the sort of diagrams that you would need to draw, I think. But there is still a lot more that we can do that we haven't quite touched on. So I also want to go over how you can draw like generic polynomials as well, and how you can add some text. So let's add some other lines first. So we're going to add one other line, draw 0, 2, 1, -3. So that should be 2 dashes like that. So you've got another line coming off there, and I'll just zoom in a little bit so it's easier to see it. We've got some sort of like pulley set up here, right? So 2 things on either sides of a pulley, and they're going to be balancing each other. So one of them is going to be a triangle. How do we draw something like that? How do we draw like a complex shape? So we start off with fill draw. I want it to be red. And we're going to have the top corner be at 1, minus 3. So at the end of that longer line on the right side of the circle. And then I want the next coordinate to be 0.2 to the right of that, so 1.2. And then 0.3 below that, so minus 3.3. And then I want it to be symmetrical, so the other point should be 0.8, and then minus 3.3. And that's sort of added our triangle. There's one problem which I don't know if you can see it clearly, but there's no black line on this side because this doesn't actually join up. This one doesn't actually join up with this one. So to do that, you do 2 dashes again and then cycle. And that's particularly important if it's like a not filled in shape. All right, and there you go. So that's a little red triangle on one side. And then we can add another little circle on the other side. This one can be green. And this is going to be at minus 1, minus 2.3. All right, there we go. So now we have our experiment set up. But what I want to do is label everything in this experiment. Because whenever you're drawing a diagram in an experiment, you've got to label absolutely everything. So the way that you label something in one of these diagrams is you do node. We'll leave that the anchor part for now. We'll just say node at 1, minus 3.3. And then in curly braces, we can put the text. So 2 kilograms. So that's put our text there. The problem is it's put our text literally right on top of that point. And that point is in the middle of our triangle. So the text is sort of obscuring the triangle and the triangle is obscuring the text. So this is why we have this anchor north. That just means the text in this node is actually attached to something, to some point to the top of it. So it's describing something from below, in a sense. And that moves it down there. And so one other example is if you wanted something, let's say that we want some text up here above the pulley, this blue circle, to say pulley. Then you can do anchor south. That's going to be at 0, 1. I'm going to say that's pulley. And then we're going to add the other label here. Now you can also have maths stuff in here. So I could do like m plus alpha kilograms. And that comes out in the way you'd expect. Oh, should that be a different position? This should be anchor north, because I want it to be below that point. Yeah, and you can have maths and stuff in there as well, so that can be pretty useful. Again, that was a lot, so I'll jump back to the questions in chat. Is everyone following along okay? Because I know that the graph stuff and the diagram stuff can end up being pretty complicated. There's a lot of stuff which you just have to sort of remember the format that it's expected to be in. All right. So now let's start to go over a few of the extra content that I have prepared. There's not much in the way of examples for these things, but I think it's worth mentioning them. They're in the slides if you want to just refer back to them. So, here's an example we can go through. So let's just add some... oh, you have a question. What's up? Oh, go over the anchor again. So to give you an idea, I think I'll do just a tiny little circle where we put in the anchor. So let's say for this this label here, right, for pulley, I'll zoom in a little bit more. So this black dot there is the same, at the same position effectively as this text, so this pulley. So if I get rid of the anchor here, you will see that pulley is directly on top of that dot. It's centered as stuff as well. And it's convenient to have this because we want to just put the same coordinates in for whatever we're describing, so this point, and then the text that's describing it. But we also want the text to be sort of separated. And the anchor is like the position of the thing that the text is describing. So in this case, we want that black dot to actually be a little bit below the text. So in that case, we do anchor equals south. And so now the dot is like south of the text. We could also do something like anchor west, and then that would put it to the right, like that. Or east, we'll put it to the left. Or you could do something like northeast. So that would put it like to the left and to the bottom. So it's just an easy way of spacing some text away from what it's describing without just manually changing the position of the text to be like a few centimeters above or below that point. Can you use anchor when you have plots as well? So if you want to add like a point onto a plot, it is possible to do that. You just add a node like this and make sure you have both ticks and PGF plots as in the packages. And then you can use a node. The problem is there's one property that you need to give to, there's one property that you need to give to the plot to make it work. I'll just, actually, because we've got a fair bit of time, I'll just quickly try and do that. So let's get a graph back. So let's grab our plot from before. Oh, I need to also get PGF as well. just looking it up because I forgot what exactly the option is. I can't find it at the moment, but yes, there is a way to like put a point on a graph that you plot with PGF and then label it. But I can't find that at the moment, unfortunately. But it's certainly something that's possible because they use the same system underneath. Are there other questions about PGF and ticks that we want to go through? Otherwise, I can start talking about the other kinds of stuff that you can do in terms of like setting up a document and so on. All right. So one thing that you can do, I won't show an example in the interest of time, but it's something. These are things that I just want to make you aware of. The first thing you can do is, if you have a long document, you can just use a command called table of contents, and that automatically generates a table of contents at the start of a document. That's very useful if you've got a really, really long report. More than just a few pages, and you want to sort of make it easy to jump to a particular section. This is useful for assignments. If you want to sort of change the formatting, you can use custom headers and footers using the fancy header package, or fancy HDR it's spelled. That lets you change things like, do you want a line on the top of each document? Do you want to put your name there and the assignment name? A special formatting for the page number, for example. You can use the title sec package to change the way that the section titles look. So if you want to make them, in italics or something like that, you can do that. A little bit more on references. I already showed everybody footnote. You can make clickable links using /href or /URL if you've included the hyperref package I think you need for that. And you can use the bibliography and a special language called BibLaTeX to format your bibliography if you have a really long bibliography. The convenient part about that is that most places where you can see these references, like these documents and so on, including the UNSW library website, have just a section of bibtech code that you can copy and paste into your bibliography file, and it just automatically takes care of stuff for you. These are some like syntax tricks you can use. One thing that I find helpful is that vspace and hfill is good for spacing stuff, as well as new page to like force there to be a new page. If you're writing a longer mathematical document, you can also use like the /new theorem command to have your own separate styles for like, this is a proof of a particular thing, this is a lemma for a particular thing, and so on. You can do lists. I'll just quickly show that off. So reasons I submitted the homework late. Trimesters. Dog ate it. So if you use itemize, you get this sort of bulleted list. Or you can use enumerate, and then you can get a numbered list. And you also might want to nest some lists, so you can say like reasons I don't like trimesters. So if you have a nested list, particularly if it's like enumerate inside another enumerate, it will automatically change the numbering style for you. You can also use various text styling things. So you can use text BF for bold. You can use text IT for italics. So I'll just show you a quick example of that too. So text IT, text BF. So this is in italics now, kind of like what's, in a maths equation, and then this is in bold. And you can also do other various stylings, like change the fonts. This is useful if you're doing something like a CV or a modern document. You want to change how it looks. And I can also change the font size. We're almost at the 6 o'clock mark, so I'll try and speed things up. It is possible to have other kinds of fonts. So there's a useful link here if you want to, really make your assignments look really fancy or fool people into thinking you're using Microsoft Word by using these two packages, and makes it look like Times New Roman. I can actually try that out. We'll do it all the way down here. I don't have it installed. What about just sticks? No. If you try that on Overleaf, it will work, but I don't have that package installed. You can have colors in your text. That's useful if you have a long equation and you want to take out pieces of it. You can use xcolor, and you can use /color. You can also use /page color. And you can use both of them, let's say /page color black, /color white, to essentially put your homework in dark theme. I've done that at least once. It's pretty cool, but I think you'd probably get told off if you submitted that. It is possible to have source code listings in a more convenient way. There's not enough time to go over this, but you can look into these packages if you're doing a computer science thing and you want pseudocode or source code or an algorithm or something like that. And it's possible to do some presentations. If you're giving a presentation about some sort of maths that you've done, you use Beamer. That's what I use for these slides. Just a reminder that I've put these helpful links at the end of the document, and I would appreciate it if you fill out this feedback form so that if we run this workshop again in the future, then it can be a little bit better than this time. So, any final questions before we finish up? How do you put spaces between paragraphs? So let's say that I have two paragraphs here. So if I have those two paragraphs, then there is no space between them. That's because if there's just one new line, LaTeX sort of ignores it and says, well, that's actually just part of the same paragraph. So I have to I either specifically add another new line between them, which will look like this, or you can have two backslashes, the same as if you had a table or something. And if you want a lot more space, you can use vspace. So vspace 1 centimeter, for example. This is useful if you're doing sort of your own formatting stuff. And it gives you a little bit more space. that's it. Well, thank you very much. Thank you everyone for coming. I hope this was useful. I wish you good luck in all your maths assignments. I understand that 1A has just released its assignment, so I hope everything goes well with that. I will put all the slides and all the examples and some useful templates up, and I'll give the link on the event page. So yeah, and please fill out the feedback form for us. That would be much appreciated. All right, thanks everyone for coming.